So this is lecture 1 about electromagnetic wave and Maxwell equation. Okay, so before going into, let's review what is light. Right. So what is light? Because in this lecture, we are going to study the photochemical or photophysical processes related to the photo devices. So I always light is involved. Right? So light is called as another name. It's called electromagnetic wave, right? Because, for example, light is propagating in this direction, okay, and then electromagnetic wave, meaning light is basically the oscillating electric field. Electric field is oscillating like a wave. And at the same time, in the vertical direction, there's a magnetic field oscillating at the same wavelengths too. That's why the light is called electromagnetic wave. Right? And there are not so many parameters for light itself. And as I always explain that in many photochemical processes and photophysical processes, light itself, there's not so many variations. It's actually there are very few parameters to define the light itself, which is are two parameters. The one is the lambda, meaning the wavelengths, and this determines the color of the light, right? And the other is the amplitude of the electric field or magnetic field, so amplitude, which means this determines the intensity of the light. These two are the necessary parameters if you need to define what kind of light you are using, okay? Because light is a kind of the wave, type of wave, but this one is quite special because only in the wave phenomena, only the light has a constant velocity, which is 3 times 10 to the 8 meter per second. Right. That's why when we frequently need the frequency of the light or energy, which is determined by, in the case of frequency, C over lambda, and the energy is equal to Planck constant times frequency, which is determined once you determine the lambda, right? That's why the light itself has very limited parameters you can control. Actually, many of the variations of photo devices or photo processes are mostly determined by the materials side, because materials has many different properties and parameters. Okay. So, and then this, again, the light has electric oscillating field and magnetic oscillating field, and then meaning the light is made of the electric and magnetic field. That's why it is called electromagnetic wave. This is described by the Maxwell equation, and because this one Maxwell equation always basically gives a magnetic field and electric field by using the several basic equations. And before going into the equation expressions, for many of the undergrad chemistry students don't like equations. So I will at first give you some impression how to understand and what these Maxwell equations means. So there are 4 equations in Maxwell equation. So and here are the kind of summary what these equations means. Okay. The first up here, figure 1, if you put a charge or positive or negative, right, and this charge gives an electric field surrounding the charge, right? And then if you use a negative charge, the direction is opposite. This is one of the things. And if you put a magnet, right? If you put a magnet in center, again, you can generate the magnetic field around the magnet. These are the first 2 equations. And the second thing is here, if you have a wire and some electron is propagating, meaning the current flow at some constant speed. And as you know, in the high school physics, if the current is flowing inside the wire, you can generate the magnetic field around the wire, right? Like this kind of rotational magnetic field is generated. Right? And the other point of this is here in figure 1.3, which means charge, this time charge, positive or negative charge, is not at a uniform motion, but it's now accelerated. It's gradually getting faster. And in this case, this motion gives electric or magnetic field. And at the same time, if this kind of charge is gradually bent like this bend, meaning there's some acceleration in the vertical direction like this. In this case, this one also gives electric and magnetic field. So in summary, in this case, if the motion is acceleration, if there's some accelerating component in this direction or in this direction, you can generate electric or magnetic field. So one of the good example using this one is the synchrotron radiation, which is very strong light sources and used for the material characterization. In this case, the very fast accelerated electrons are going into the very strong magnetic field to bend the motion of the electrons. In this case, the tangential direction of the electron acceleration, you could generate a very strong electromagnetic wave. This is due to the acceleration change and then generating the electromagnetic field. So this is one technique. So based on this,